point. So I know you've done a little bit of work on this already, but just so that we can go over what we're going to learn today, we're going to be able to differentiate between relative humidity and dew point. So these two things are different. They have some similarities, but they're not the same. We can explain how saturation is affected by temperature, and we're actually not going to do this part for now. So we're going to skip that. So here's your success criteria. So what we're not going to worry about right now is using the reference table to calculate relative humidity and dew point. All right, so what we want to think about first is, what does it mean when someone says it's humid out? So I want you to think about that for a second. So you pause the video, think about it. Okay, so think about your answer. Typically, what I hear students say is that it's hot and humid. So usually what we think of humid days, maybe like July and August in New York City, it's very hot. There's a lot of moisture in the air. Places like Florida tend to be very humid, or anywhere around the Gulf Coast, so Louisiana, stuff like that. So that's usually kind of what we think about when we think of humid, or like a rainforest, whatever. Okay, so now we're going to talk about this word saturation. So I'm not sure if we've talked about this word before. So when you think about saturation or saturated, it's an example might be like a sponge. So if you have a sponge that's really wet and it's dripping with water, then I would call that saturated. So anything that's basically full. So if it cannot hold anything else, or cannot hold any more than it has, then that would be saturated. So in this case, we're talking about air. When the air is holding as much moisture as it can, we say that it's saturated. The warmer the temperature of the air, the more moisture it can hold. So the hotter it is outside, the more moisture that the air can hold, or the more moisture that can be contained in the air. And the opposite is also true. If it's colder, you can hold less temperature. So this is one of the reasons why your skin gets very dry in the winter. Cold air can't hold as much moisture, so the air is very dry, which causes a lot of us to have problems with dry skin. I know I am someone who has problems with getting dry skin in the winter. If the temperature is lowered enough, so if we take the outside temperature and let's say we don't change anything else, we just change the temperature. If we lower it enough, the air becomes saturated. So here's a diagram about how warm and cool air. So remember, warm air rises, right? Cool air sinks. A parcel of lighter, warm, moist air, you have abundant space available to hold water vapor. So you have air molecules here, right? And they're spaced out. So there's room in those air molecules for water to be contained. If you have cold, heavy, dry air, there's less space in between. So there's not as much space for water in the air. So we're going to talk about this idea of relative humidity. So remember, the word relative is a comparison. So relative humidity expresses how full of moisture the air is compared to how full or how much it can hold. Okay, so it's a percentage. It's like a ratio. So compare how much moisture is in the air to how much it could hold. Air is saturated at 100% relative humidity. So this doesn't actually tell me how many grams of water are in the air. You can find that out using different kinds of calculations. It's not anything we're going to learn about in this class, but there are ways to figure out the amount of actual water in the air. So this doesn't really give you a ton of information, because remember, cold air holds less water. So 100% relative humidity at 32 degrees is going to have a lot less moisture in the air than 100% relative humidity at 95 degrees. And this diagram shows us that. So if we think about the same amount of water being present, and I am raising the temperature here, okay, the lower the relative humidity is. So at 10 degrees Celsius, this is full. So we're going to say it's 100% relative humidity. 20 degrees Celsius, okay, so now there's more space. So it's about 52% relative humidity. And then at 30 degrees Celsius, which is about 85 degrees or so, it's 28%. So each of these three has the same amount of water vapor, but the relative humidity is different because air can hold a lot more water when it's warm, which is why it's not a great measurement of how much water is in the air, but it's just something that's used frequently. So when we find relative humidity or dew point, we use something called a sling psychrometer. It has two thermometers, one called the dry bulb. One is covered in a wick, like a piece of fabric that has been moistened with water, called a wet bulb. And you swing it around until all of the water from the wick evaporates, so you can measure the wet bulb temperature. This temperature is always lower because of the evaporating water. So evaporation is a cooling process. The reason we sweat is because when that sweat evaporates from our skin, it actually cools our skin down. So when this water evaporates off of the thermometer, it cools the air around it, so it actually lowers the temperature of the thermometer. So when we talk about measuring moisture, the amount of evaporation depends on the moisture content of the air. So we're still talking about the sling psychrometer. The lower the moisture content of the air, the more evaporation will occur. Okay, so the less water in the air, the more evaporation you're going to get, and the cooler the wet bulb temperature will be. So if your temperatures are very close together, then you have a relatively high relative humidity. If your temperatures are far apart, you're going to have a low relative humidity. And there's something else we're going to talk about that also sort of measures moisture. It's called dew point. So dew is that stuff outside that you see sometimes in the morning, especially in the summer. If it's cool in the morning, if you're lucky enough, you might see water on the plants or maybe on the cars or on the sidewalk railings, whatever, early in the morning. That's dew, okay? So the dew point is the temperature to which the air must be lowered to become saturated. If temperature falls below dew point, condensation occurs. So if the outside temperature falls below the dew point, you get this dew or condensation. The greater the amount of water vapor in the air, the higher the dew point. Okay, so a dew point of 75 tells me that there's more water in the air than a dew point of 25. So this goes over what I was just saying. Dew point temperature is also called the dew point because dew or frost forms on exposed surfaces when the outside temperature falls to the dew point. So just here's an example of dew. All right, so if we want to raise relative humidity, if you want to see relative humidity go up to 100%, okay, there's two ways you could do it. You could either cool the air to the dew point, so you could not change the amount of moisture in the air. Okay, you could just cool the air down to the dew point. That would increase the relative humidity because remember, as you decrease the temperature, air holds less water. Or you could increase the water vapor in the air, which would be raising the dew point. So if you add more water into the air, then you're obviously bringing up your relative humidity. So this is important here. When air is saturated, the relative humidity is 100% and precipitation is likely. So if you remember looking at our weather data that we collected, we noticed that the days that had a high relative humidity, it was either raining or cloudy or foggy or something like that. Okay, so the closer we are to 100% relative humidity, the more likely we are to get precipitation. So that's really it as far as the content of this lesson goes. So just to do a few review questions, Question 1. To say that the relative humidity on a given day is 70% means that the air is, or the air so the answer is 2, holds 70% of its water vapor capacity. If the amount of water vapor in the air increases, then the dew point will also increase. As the air temperature rises, the relative humidity does what? It's going to decrease as long as you don't change the amount of moisture in the air. All right, and so that's it for this lesson. Just to go back and look at our learning target, I can differentiate between relative humidity and dew point. So hopefully you can tell me the difference now between those two, and you can explain how saturation is affected by temperature. So how does getting to 100% relative humidity affected by temperature? And calculating relative humidity and dew point, remember we said we were not going to worry about this right now. Okay, so hopefully that was a helpful explanation. As usual, let me know if you have any questions about anything, and I will be happy to help you.